Okay, here's a couple questions where you have to write as a single logarithm, so you have to squish them. Both these questions, though, are a little trickier because you have a couple of factors there. So it's a minus, so I want to squish them. So the rule is the ln of A minus the ln of B would be equal to the ln of A divided by B. So that's sort of one of the rules I want to use. But then there's another rule that says the ln of A squared is the same as 2 ln A. And so if I have a number out front of a ln, it can go back up as an exponent. And that's what I want to do with both of these first before I start squishing things. So the first thing I do is I'd pop this back as an exponent of this whole thing. So let me write what we have. So ln of 4w to the 6th. And that 3/2 I'm going to put right up there. Minus, same thing with this one. So it'll be ln of 2m to the 5th all to the 4 over 5. Okay, that's a power rule. Okay, now let's use exponents to figure out what this is. So there I have a product here, so this exponent has to apply to both things. So I'm going to go ln of 4 to the 3/2 and w 6th to the 3/2, and I'll multiply that to the 3/2. Minus, same thing over here, ln of, I missed an end bracket there, ln of 2 to the 4/5 and m to the 5 to the 4/5. Okay, that's looking a little tough. Now let's just do this on decimals, 4 to the 3/2. If it's a number, I could do that. So let me insert a browser, go to decimals. So I wanted to go 4 to the, and then in brackets, 3 divide 2. Okay, end my bracket. Comes out to 8. Excellent. So this then will be ln of 8w, and now this 6 times 3/2, I could do that on decimals too. 6 to the 3/2, or 6 times 3/2. 6 times 3 divide 2 comes out to 9. So this will be w to the 9. Oh, a little deeper. Okay, minus ln. Let's do the same thing on this side. So 2 to the 4/5. I wonder if that comes out even. 2 to the bracket 4 divide 5. Oh, that doesn't come out even. 1.7 something. Let's just leave it as it is. So just leave it as 2 to the 4/5. And then 5 to the 1/5. No. 5 to the 4/5. If you multiply those, I think that just comes out to 4. So m to the 4th. Okay. I've made things big and small here. So I have, let me just write down what I have. Ln of 8w9 minus ln of 2 to the 4/5 m to the 4th. So now I have this rule right there. So I've got it so that I have ln of something minus ln of something. Okay, so I can now apply that quotient law. So it'll be the ln of something over something. The 8w to the 9th goes on the top, and the 2 to the 4/5 m to the 4th go on the bottom. Now, in just taking a look at their answers, I need a W9 on top and M4 on the bottom. It looks like the only one that's right would be, whoops, that one. But where are they getting the 2 to the 11/5 from? I've got the other stuff, but I need 2 to the 11/5. Okay, so in looking at the question, I look at this 8 and think, well, that could be 2 to the some power. So 8 is the same thing as 2 cubed, W9, over 2 to the 4/5, M4. So I know these two are done. I can't do anything with those. But here I have like bases. So if I have like bases, I can subtract their exponents. So I'm going to go 3, take away 4/5. Let's do that on decimals again. 3, take away 4/5. 3, take away 4 divide 5. 2.2, let's make that a fraction. Oh, 11 over 5. Oh, and that's what they had. Got it like that. Ah. So this would be the ln of, these two I've combined now to be 2 to the 11 over 5. And then the W9 stays on top, M4 on the bottom. That's a lot of stuff to keep track of. Let's try another one. Oh, great. Looks like this one I have to go backwards. So I've got to take this one and spread it out. But then I've got a radical in there too. But I do know that a radical, if I have, say, the fourth root of a to the third, that's the same as a, and then you express it as a fraction, so it'd be 3 over whatever that index is. So I can do that with this one too. So I can take this and just write it as log base b of x to the 8th b squared over y to the 4th z to the 16th, all to the, now this whole thing I could think of it as being brackets and the exponent of it would be 1. So this then, instead of the radical, will be to the 1/4. Okay, so now this 1/4 I can multiply it by each of the exponents that are in the expression there. So x to the 8th, 8 times a quarter would just be 2. Oh, I forgot my log in front. Log base b. X squared, okay, b squared to the 1/4 would be 1/2 over y to the 4th to the 1/4 would just be y. And then z to the 16th to the quarter, so 16 times a quarter would just be 4. Z to the 4th. Okay, so what I was doing there, like on the y to the 4th, I was just raising that to whatever this exponent was there, and it was 1/4. So if I go 4 times a quarter, it just gives me 1. Okay, now I can express this as a sum and difference of logs. Let's first deal with the quotient rule. So if I'm dividing, I could rewrite this as log base b of x squared b to the 1/2 minus log base b of the denominator, y to the 1st, z to the 4th. Do they have that? No. But it looks like I'm heading in the right direction. Now this here would be the product law. So I could rewrite that as log base b of x squared plus log base b of b to the 1/2. Oh, there's a bb there, but we'll be able to do something with that. Okay, minus, and now since there's two things happening here, this is a dirty, rotten, filthy, stinking negative. So I'm going to put a bracket here and write the product rule for this one. So it'd be log base b of y plus log base b of z to the 4th. Okay, still going. With this first one, I can use the power law to bring that out front. So 2 log base b of x plus, since these match, b and b, my answer to that whole thing is just 1/2. Do they have that? Log base b of x plus 1/2. Oh yeah, this one and this one. So these two are out. So between these two, okay. And now, since this minus is out front, it has to apply to both of these. So it'd be minus log base b of y minus log base b of z to the 4th. Last thing I could do is I could take that power and bring it out front. So 2 log base b of x plus 1/2 minus log base b of y minus 4 log base b of z. I'm going with that one. Okay, those are two really quite tough questions. But so a combination of using exponent laws and log laws to either expand or shrink logarithms. Hopefully that helps out.